If there is one thing which is most useful in the entire chemistry, it is separation techniques, practical organic chemistry. So here is a rapid fire waiting for you. 10 questions. Do let me know in the comments below how many were right, how many were wrong. If you're liking the session, do hit the like button. With this, let's get started. Question number 1 on your screens now. First question, Chromatographic technique is used for the separation of options: small samples of mixture, plant pigments, dye stuff, or all of these. Well, you must know that we can use chromatography for not just separation but also isolation, purification. So it's a wonderful, relatively new method, and we cannot just use the chroma products, the colored product, but also the pigments, the dye, the small samples, everything. So D becomes the answer to this question. Question number 2 on your screens now. Oils are purified by. So now the body of the question might change, but the soul of the question will remain the same. See, there are different types of distillation. What are the different types of distillation? One is a simple distillation. When the difference in the boiling point is appreciable, we make use of the simple distillation. What should be the minimum difference between the boiling point? Around 15 degrees Celsius plus. If it is less, then we may use fractional distillation. If, let's say, something is decomposing before reaching the boiling point, we must use the, remember which law? Gale-Lussac law. GV, volume constant. So if the pressure is reducing, the temperature will reduce, so the boiling point will reduce. So basically we will be able to get the stuff before reaching the boiling point. So we can use vacuum distillation, that is distillation under reduced pressure, and steam distillation when we have to make something steam volatile. So the steam will be formed with that our molecule, which is generally organic molecule, which is generally immiscible with water, but with steam we can collect it. So oils are purified with, you must know, steam distillation. It's a takeaway question for you, and I'm sure now you know. Next question. The best and the latest. So I told you chromatography is relatively a latest technique. So from here only you should know the answer, but let's read. The best and the latest technique for isolation, purification and separation of organic compounds is crystallization. Sublimation. Distillation, not so latest. Chromatography is relatively latest, and like I told you, there are many types of chromatography. New chromatographies are coming our way. So chromatography, B becomes the answer. Question number 4. The distillation technique most suited for separating glycerol. Now the speciality of glycerol is before reaching the boiling point, glycerol will undergo decomposition. We do not want that decomposition, right? So what to do? Reduce the pressure. What else? What will happen if you reduce the pressure? It will undergo boiling. That means it will change its phase before reaching its original boiling point, at which probably it would have actually got decomposed. So before reaching the boiling point only we are separating it, thanks to the reduction of the pressure. Gale-Lussac law we can apply. So you should know GV, Gale-Lussac law, volume constant. Hence, if the pressure is low, the temperature is low. There is a direct relationship between temperature and pressure. So boiling point decreases on reduction of the pressure. So either the answer could have been vacuum distillation or option C, distillation under reduced pressure. Both means the same. Next, steam distillation once again is applied to those organic compounds which are steam volatile and, hello, if you remember, oil purification is done by steam distillation. Oils, is it soluble in water? No. Is it sparingly soluble in water? No. Is it insoluble in all solvents? No, right? B becomes the answer. Insoluble in water. We know oil is not soluble in water, so B becomes the answer. So that was a takeaway question that can be extrapolated here with question number 5. Next question, question number 6 on your screens now. Distillation involves all the following processes except change of state. So of course there's a change of state. Liquid is going to gaseous. So A is right. Boiling means there is a change of state happening, liquid to gas. Condensation, of course, we're making use of the condenser and hence we're getting the liquid in the conical flask, right? Okay, evaporation. Hey, if you're boiling, there's no evaporation happening, so D becomes the answer. There's no surface phenomena of evaporation happening with our distillation, of course, so D becomes the answer to this question. Next. Chromatography is a valuable method for the separation, isolation, purification, identification of the constituents of a mixture. It is based on the general principle of phase rule. So there's nothing as such where we have done phase rule, or it cannot be interphase separation. That's also something that we know. Interphase separation sounds kind of like tricky, but there's no definition as per chemistry that we have done so far of interphase separation. It's certainly not distillation. Let's understand through the example of the partition chromatography. The example of the partition chromatography is paper chromatography. So what is happening in paper chromatography? We have a stationary phase and we have a mobile phase. Stationary phase is our chromatography paper only. The mobile phase is the liquid that we are adding, the solvent that we are adding, which is moving up. So continuously our solute is, or the dye or whatever mixture that you want to separate, isolate or purify, is undergoing the distribution. Remember, a separation or a distribution in two phases, mobile and stationary, mobile and stationary, mobile and stationary, hence partition chromatography. So B, phase distribution, becomes the answer to this question. Question number 8. The most suitable method of separation for 1:1 mixture of ortho and para-nitrophenol is, so right answer to this question is not chromatography. We know that the separation method here, it cannot be crystals, there are no crystals formed, no sublimation, there's no solid to gas directly going. Steam distillation should be the answer. So you know that we make use of the steam volatility of the orthonitrophenol, because of which it can be collected with the steam and hence you can do the separation. So steam distillation becomes the answer to this question. Question number 9. Turpentine oil. See, I can make the question different, but the soul of the question remains the same. Like I said, the body can be changed. Like turpentine oil can be purified by. So I can write castor oil, I can write cannabis oil, I can write any oil. You can make use of any oil. You can take any oil and purify it using, like we did it, steam distillation, right? Oils can in general be purified by steam distillation, and you know the speciality of oils, it is immiscible. It is not soluble in water. Last question of the day. Which of the following is structure of a separating funnel? So you can see, you should know the separating funnel, how the separating funnel looks like. It's not the normal funnel. B cannot be the answer, which is normal funnel. It is neither C nor D. A is the separating funnel. It is J mains question of 2022. So A becomes the answer to this question. Hey, do let me know in the comments next rapid fire of which chapter would you like to see, and I will come up with that rapid fire questions. I hope you enjoyed the rapid fire questions. With this is me, Nitika, signing off. Take a good care of yourself. Bye-bye.